Hello, I am Riley Knorr. I am here to teach you about the hydrologic cycle, or as it's more commonly known, the water cycle. Before we begin, though, I think that we should learn where all the water on Earth is theorized to have come from in the first place. Once our little planet was a terrifying ball of superheated liquid rock called magma. Magma has water at equilibrium within it called magmatic water or juvenile water. This, along with rampant volcanic activity, meant that a lot of magmatic water was moved around and that water vapor was burst forcefully into the air from the eruptions. As you know, though, heat gradually dissipates and this allowed rock to form and air to cool. This cooling of the air meant that water vapor would begin to lose energy. When water vapor molecules lose energy, they begin to slow down and condense. This process is conveniently called condensation. When these molecules begin to congeal with each other in bits of dust, they form a beautiful little cloud, or in the most likely case with early Earth, awe-strikingly massive clouds. We've learned from experience that normally lots of big clouds means a whole lot of rain, and oh did it rain. From what scientists have analyzed, there was a lot of rain in early Earth. So much rain, in fact, that the world went from a massive fireball to a massive ocean. Now, with all this water laying around, we can finally start the water cycle. There is a small flaw with the statement that I just made, as there is no real start to the water cycle, but we should begin where we left off when we discussed the creation of water, the ocean. This is where most water on planet Earth exists. Small quantities of water are always being evaporated from the ocean by the heat of the sun. The heat agitates and energizes molecules in the water, and they begin to move faster and more erratically, eventually to the point where they become so loosely packed that they become a gas. We're not talking gases and petrol fuel, as you can imagine. In this case, a gas means that matter has enough energy that the molecules are moving so fast and far apart that they are no longer confined by a dense solid shape or even a less dense non-constant liquid form. Because of this, gases tend to float around instead of stay on the ground, but there are a few exceptions. Though I've established that it's water that turns into vapor, it's not the only thing that does. Ice and snow can sublimate directly into vapor instead of turning into water and then vaporizing. Then the vapor is carried upwards into our atmosphere along with the water from the process of evapotranspiration. Evapotranspiration is the loss of water to the atmosphere from the surface, from groundwater, and water that is produced by plants in the process of transpiration, which is when the plant emits water which is theorized to improve their nutrient intake. When all of this vapor and water rises into the atmosphere, it cools. This cooling causes it to condense into clouds. Clouds move with the wind all around the planet. I'd bet that you've seen some clouds around your neighborhood from time to time. As these airborne puffballs blow nonchalantly across the globe, they gradually collect more and more vapor. When they collect vapor, they grow and they grow and they grow. Eventually, the little lighter-than-air cotton balls are massive threatening sheets of darkness blocking out the whole sky. These massive shadowy curtains of water vapor mean that precipitation is coming. Precipitation is what you might call rain, snow, sleet, or hail. Via this process, water returns to the Earth. Some of this water will pack into snowcaps, ice, or glaciers. Some of this water, instead of chilling out, gets on the move. This running water forms rivers and streams. Rivers and streams come from a static body of water, usually a pond or a lake, and normally flow back into a static body of water like a sea or an ocean. Yes, some water does that, but most of it soaks through the ground as infiltration water. Portions of infiltration water replenish natural stone water storages called aquifers. Some other water stays relatively close to the surface and may run back into ground bodies of water like lakes, ponds, oceans, seas, natural springs, and other above-ground collections of water. This is called groundwater discharge. Yet even more water is absorbed by plant roots and re-released by transpiration. Over time, though, all water keeps on moving. This is where the water cycle ends or begins, depending on your perspective of the cyclical nature of all water on our little planet. Thank you for sitting through my video.